Electrical properties of nerve fibers can be easily remembered using this ER-cis, that is expanding to E for excitability, A square all or none law accommodation, R for refractory period, C for conductivity, I for infatigability, S for summation. Starting off with excitability, it is the property of virtue of which various cells respond to changes in the external or internal environment. Excitability occurs due to disturbance in the ionic equilibrium across the receptive zone of cell membranes. We all know stimulus could be thermal, chemical, mechanical, or even electrical. Now there are certain factors that affect excitability. So the strength and duration of stimulus, as we can see here, reduced extracellular fluid, carbon dioxide increases excitability. Increased extracellular fluid, carbon dioxide also stabilizes the membrane, thus leading to depolarization. We can see here in this SD curve, there is resting potential being minus 70 millivolts. When there is sodium channel opening, there occurs depolarization, and when there is repolarization, the sodium channels closes and potassium channels opens up, then causing a dip, and that is known as hyperpolarization. Next one is the all or none law, which says that when a stimulus is applied, the axon either doesn't respond or it responds to a maximum of its ability. Next is accommodation. So that says that if a nerve is submitted to the passage of a constant strength of current, the site of the nerve that is under stimulation shows decrease in the excitability, thus increasing the threshold of the stimulus. And if this occurs in nerve endings, it is called as adaptation. Next, refractory period. So this basically says that if there is two successive stimulus of more than threshold intensity are applied to a nerve, the nerve is unable to respond to the second stimulus for quite some time. Thus, the nerve becomes refractory, that is non-responsive. The length of time it remains refractory, it is called as refractory period. We have an absolute refractory period and a relative refractory period. Absolute is where the neuron doesn't respond to the second stimulus in the depolarization phase. Relative refractory period is when the neuron responds to the second stimulus on repolarization and hyperpolarization phase. Then we have conductivity. Now, when the nerve impulse is conducted along the nerve fibers, that is, the propagation of wave of depolarization occurs. There is unmyelinated fibers and myelinated fibers, as we all know. So when we see in the unmyelinated fibers, the conduction occurs through current of sink, as you can see here in the diagram. This is the normal polarized state, and here there is a current of sink. But when fiber is excited, the polarity is reversed and the propagation of waves occurs in continuous manner. In the myelinated nerve fibers, the action potential are generated only at the nodes of Ranvier. So depolarization jumps from one node of Ranvier to another node of Ranvier, thus leading to saltatory conduction. Now conduction under saltatory conduction, it could be of two types, orthodromic or antidromic. Orthodromic is when the conduction occurs from the synaptic junction to the terminal cisternae. Antidromic is when the conduction occurs opposite direction. Next is infatigability. Very simple. The nerve cannot be fatigued even with the continuous stimulation. Why? Because nerve fibers conduct one action potential at one time. Summation is when two or more stimuli are applied together within a certain interval of time. There will be a summation of impulses.